Okay, here we go. This is assignment G. This is antiderivatives, definite integrals, and we begin off with a pretty advanced level of the average value. So before we get to this point, let's learn about definite integrals and how to take them. All right, so we're jumping kind of a little bit more forward than I was really expecting, but here we go. So we were learning over the last few lessons, one, what an antiderivative is, and then we were learning how an integral is the area underneath a curve. So if I have, some graph of the, like, let's say, negative x squared plus 4 or something like that. And so it would look something like this. What an integral does is it finds the area underneath the curve. How this would look as far as a definite integral would be is this would be at what, negative 2 and 2. And so what this integral would look like is I'm going from an x value from negative 2 to positive 2. And I'm finding the area of 4 minus x squared. That's the same equation, dx. And then this will give you that area. This will give you that area of the blue. Now, sometimes there's an easy peasy way of figuring it out, whether if it's, like a simple geometric shape. But other times, like in this situation, it is not easy peasy. All right, so what do I do to physically find this area? Okay, well, first what we do is we take the antiderivative of this equation right here. So in essence, take the integral. So that would be 4x minus 1/3 x to the third. Now, if these numbers weren't here, you would say plus c right there, and that would be the antiderivative, or the integral, the indefinite integral. But because we are defining where it begins and ends, this is a definite integral. It's defined. It's a definite integral, as opposed to an indefinite integral. So what we do is we do this anti-differentiation, this integral. And then we put these big old square brackets around it, and we move these numbers over here to the right-hand side. You can't see where I'm pointing. Over here. All right, so again, this is the upper bound, and this is the lower bound. Okay? What you do to get this answer is you evaluate this equation, this integral, at the upper bound, okay, minus the integral evaluated at the lower bound. So this is going to be 2 minus 1/3, 2 to the third. That's the upper bound. And then minus this at the lower bound. So negative 2 minus 1/3, negative 2 squared. So the evaluation at the upper bound minus the evaluation at the lower bound. All right, so this particular case is what? 8 minus 4/3. This is 20/3 minus negative 8 minus, again, 4/3. Negative 28/3. So this is 20/3 plus 28/3. So this area is straight up 16. The area of that blue region is straight up 16. No, it's not. Made a mistake somewhere. Sorry. Give me 1 second. Sorry. I'm sorry. I apologize. Oh, I'm stupid. One mistake. Ooh. I'm slipping, folks. All right, sorry about that. I just had a complete brain fart, and I was squaring the two, not cubing the two. So the first one is 4x minus 1/3 x to the third. So this is 16 thirds minus -2 going in for x, which is again -16 thirds. And so this is what, going to be 32 thirds. Yeah. So 32 thirds. My bad. All right. Ugh, sorry about that. Here we go. Yeah, so 32 thirds is that. I'm sorry, I had a complete brain fart. Right, all is well in the world. So that is the area of the blue. My bad. Area of the blue. So again, what you do is you take the antiderivative, you write it this way, and then you do the upper minus the lower. And a lot of times you are going to create this like minus of a negative and things like that. So don't be afraid of those, but just follow the process. Follow the process and you'll be fine. All right, so this is how you evaluate a definite integral. All right, now, and again, they're starting you off at such an advanced level that it's crazy that what they are asking you first and foremost about is this thing called an average value. An average value. And so, like, say, take this problem for instance. What is the average value of this? And so the idea is this. If I'm going to construct a rectangle on the same interval from -2 to 2, aka this has a base of 4, what is this height? What is this height that will make the area of this rectangle the same as the area of the blue curve? What is this height? And this is called an f of c. This is the average value. This is the average value. This is literally what it is. It's the average of this. And so the average value is this. So again, if I put this in terms of a rectangle, this is going to be equal to the area of the rectangle, which is the base times the height. So if I have 32/3, and I ultimately have to divide by 4, the average value of this, the average value is going to be 8/3. That's the average value of this. So this would have to have a value of 8/3 for the area of the rectangle to be equal to the area of the curve. And that height is an average value. I'll help break this down when we get to like some more of these, but that's the idea of what an average value is. It's the height of your rectangle. What's the height of the rectangle to make the area of the rectangle equal to the area of the curve? Okay, so find the, shoot, I think we actually just straight up did this problem. So let's do it more formally. Let's, instead of scribbling all over the place, let's show what this is actually going to look like. All right, the average value. What I do is I start off with the rectangle, which has a base of b minus a. This is going to be f of c, and this is going to be the integral from a to b of f of x dx. This is formally what you do. So again, this is the area of the rectangle. This is the area of the curve. This is the area of the rectangle, base times height, and that's the area of the curve. So what this is going to be is this is going to be 2 minus -2. From -2 to 2 of 4 minus x squared dx. A lot of stuff going on here. Okay, so this is going to be 4 times that average value. Again, f of c is the average value. And I evaluate this integral. So this is 4x minus 1/3 x to the third. And this is being evaluated from -2 to 2. All right, here is where I kind of use my calculator to help with these calculations. So what I'm talking about is this. I'm going to evaluate this at 2, and then I'm going to evaluate it at -2, and then I'm going to, in essence, subtract these answers. So here's what this is going to look like. I use my calculator, and I store 2 in for x, and I plug it in. So 4x minus 1/3 x to the third. That answer is 16/3. So that's what I write. So 16/3 minus, and then I repeat that process. So I go -2, store x. And again, how I walk backwards in my calculator is I hit second. I don't know if you know what I'm doing, but I'm hitting second, enter. So that's like second in that the gold writing is, what is it, entry? So I get second, enter, and it walks it back. And I hit it again and again and again until I come up with the equation that I originally used. So now I'm plugging -2 into the equation that I have up on my calculator. And so this is -16/3. Okay. So that is the evaluation of that integral. And now what I'm also doing is I'm going to bring over the 1/4. I divide by 4. All right, so all together now. The inside is going to be 16/3 minus negative 16/3, and then I divide by 4. So this average value is equal to 8/3. The area under the curve, and this is going to be a lot of the questions, is straight up just that portion of the question. So that's the area of the curve, and then the rectangle was 4 times this height. This was the height of the rectangle, and then the base was divided off. Okay, and this is, again, the average value of something. So again, picture-wise, what the heck this means is this. I had this curve, and then I construct a rectangle with the exact same base, and the area of the rectangle is equal to the area of the curve. So in essence, this extra area right here is equal to this extra area right here. All right. So let's go ahead and find this average value. So let's set up our rectangle. The base is 1 minus negative 1, and the height. That's going to be equal to the integral from negative 1 to 1 of 2e to the x dx. I guess I haven't talked about an integral of e to the x. What's a derivative that creates e to the x? Well, e to the x, of course. That one's easy. Derivatives and integrals are the same in that case. So this is going to be 2 f of c is equal to 2e to the x. And this is going to be evaluated from negative 1 to 1. Now, here's a quick also note that you can take constants out of this thing. So instead of putting the 2 and muddying the water, you can keep the 2 on the outside. All right. So this is going to be e to the 1 minus e to the negative 1. And then I'm going to divide by 2, so that turns into 1. If you don't know what I just did, this is, I divided the f of c 2 over. So this is 1 half. Okay. E itself is like, I forget what the number is. So this is just going to be e minus e to the negative 1 is 1 over e. In essence, it has an exponent of negative 1. That would be the answer. That's the average value. Okay. Here we go. Let's set up the rectangle. This is going to be pi minus 0 of the average value. And that's going to be equal to 0 to pi of sine x dx. So the area of the rectangle is equal to the area of the curve. The integral of sine is negative cosine. Then I'm going to exclude the negative, so there's a negative 1 of 0 to pi. Any constants you can get rid of. This is equal to pi f of c. Okay, so I evaluate this. This is probably going to require a unit circle. So I'm evaluating this at pi, which has a value of -1, 0, and 0, which has a value of 0, 1. And we're talking about cosines of these. So this would be the cosine at pi minus the cosine at 0. Negative. And then I divide by pi. So this is technically going to be -1 over pi. Altogether now, this is going to be -2, so this is going to be +2 over pi. Just one page. Okay. All right, so again, let me, average value. Average value is where the area of the rectangle is equal to the area of the curve. And again, this is the same base. So if you're setting up a curve, all right, that goes from, here to here, okay, the rectangle has to have that exact same base. And again, there's going to be some extra area and some under area, things like that. So the area of the base is equal to the area underneath this curve. So you set this up with the rectangle is in essence base times height, and then the curve is the integral of your function. So your base is a b minus a, and your height is this f of c. Again, we'll explain this a little bit more in a further lesson. And the curve is integrated from a to b of this. And that is the height is the average value. And again, what this value c is going to be is there's going to be a c value on the integral of a to b. The intermediate value theorem holds. All right.